In this lesson, we're going to learn about entity spawning and management. Now, in most of our examples so far, we've been creating all of our entities ahead of the main loop, and then we just let the game run, and in most cases, we haven't really been creating and destroying objects as the game runs. But in a real game, you're often going to be creating new entities and updating them and destroying them dynamically. When you do this, the new entities that are created, they must be stored in a table in order to keep them from being automatically deleted. And that table can either be a global variable or it can be attached to some other object that is responsible for managing those entities. Usually entities that are newly created, they need to be continually updated each frame. And then we need some method of deleting entities when we're done with them. This can be either done by checking to see how much time has passed and then just automatically deleting them based on after a certain amount of time, or it may be based on some other action. So projectiles are a really good example of this kind of thing, because if we're shooting bullets, we tend to use a lot of them, and we don't want the game to just fill up with infinity bullets. So we want to be able to get rid of those bullets after a while so we don't have hundreds of thousands of them. So let's copy this code, and then we're going to paste this right into main.lua in a Lua project. And I'll just show you what this does. So we have this turret in the middle, and it's rotating around to face the direction that the mouse is pointing at. And when I left click the mouse button here, I can shoot a bullet. Now it's kind of hard to see because it's pretty far away when it happens, but that bullet, it doesn't stay around forever. It gets deleted after about 2 seconds, I think. So I can shoot many of them, and they're probably all gone right now. They're probably gone. They're definitely gone now. So that's one way they can be deleted, is just simply by timing out. And then the other way is when they hit something, the bullet just disappears. You see, it doesn't go anywhere. So using this, I'm able to have many bullets in the scene. But at any given time, there's only a few of them. There's probably only 20 or so. So let's take a look at the code and see how we did that. Here we're loading the turret model from our documentation system. And then here's the turret update function. We'll skip this for now. This is where the bullets are getting updated. So we're creating a plane, and then we're doing a plane intersection test using camera screen to world. So that's camera projection. And then we're finding out where the point on that plane that the mouse is actually pointing at. And we're using that to determine the angle that the turret should be facing. And then if the left mouse button is down, then if more than 100 milliseconds have passed since the last time a bullet was shot, then we're going to shoot another bullet. What is a bullet? Well, we're going to create a sphere. We're going to set its position to the gun's position, and then up a little bit. We're going to rotate it to match the angle of the gun, and then we're going to, that's enough right there. And that's the point where it's going to be shot from. And then, most importantly, we're going to insert the bullet into this bullets table. This is self.bullets. What's this? Okay, here's where it's created. Here I create the turret by loading a model. I say load turret equals load model and then turret.bullets equals a new table. This is very important. This means that the turret has a container where all the bullets are stored. So the turret basically has ownership of the bullets. And when a new bullet is created, we call table insert to insert a bullet into this self.bullets table in an array style table. So this will insert it with an index. So the first one, the key will be 1, and then the value will be bullet. When the second bullet is created, the key for the table will be 2, and the value will be bullet. So this is an array style table. Okay, and then going back up to the beginning of the turret update function, we're going to iterate through all of the bullets in this table, self.bullets. For each one of these, we're going to call transform normal to transform the vector 0, 0, 1 from the bullet itself to world space. That's what nil means. So we're transforming from local space to world space this vector 0, 0, 1, which is 0 on the x-axis, 0 on the y-axis, and 1 on the z-axis. So in other words, that's going straight forward. So we want to find the direction, the vector, that the bullet is pointing. That's what that gives us. Then we're going to perform a raycast using this world pick method. The starting position is the bullet's current position. The ending position is going to be the bullet's current position plus this direction. We have the closest parameter set to true because we want to make sure we find the closest intersection that occurs. And then if any intersection occurs, then for whatever entity was picked, we're going to call add point force, which is going to add a force at a specific point. That force is going to be the direction of the bullet times 6. That was just the value that I found that seemed to work the best. The position is going to be the picked position, and it's in global coordinates, so we'll set this to true. And then we're going to say self.bullet set hidden true. Okay? If nothing was hit, then we're going to move the bullet forward. Okay? Now, if the bullet's spawn time, which we set when it was created, right here, see bullet.spawn time equals now. What is now? Now is, we get this right up here at the beginning of the method. It's self world get time. That gives us the current time. And that's actually going to stay the same all throughout this method. It doesn't change until the next call to world update, but we'll just get it once. So if now minus the bullet's spawn time is greater than 2000 milliseconds, then we can also hide the bullet. Okay. Well, if the bullet was hidden for any reason, it's gone. We're done with it. We don't need it anymore. So we can call table remove self.bullets and then provide in the index to tell it the value to remove from that array style table. So that gets rid of the entity from the table, and that keeps this table at a manageable size. In fact, I want to show you something. Let's see, turret, bullets, okay. I'm going to say window set text to string. I just want to show you the size of this bullets array as we're using it. I want to show you how big it gets. So right now it's 0 because we have 0 bullets. And then it's 1. And then it went back to 0. You see that? Let's see how high we can make it. Okay, so you can see it's going up to about 17. And that's as high as it ever gets, even though I'm shooting hundreds of bullets. At any given time, there's only up to about, in this case, it looks like there's about 17 maximum bullets at any given time. So that's a very manageable number, and that ensures that we don't slow our game down by having millions and millions of bullets that never die. Now, something really important to point out here is when we're doing dynamic array removal, we actually want to iterate through the array backwards. So in other words, we're going to start, instead of going from 1 to the size of the array, which is what this hashtag means, we're going to start at the size of the array and finish at 1, and we're going to step backwards we're going to step through by -1. And that's what I already did up here. See, we're not doing it like this for n equals 1 self dot bullets do. We're not doing this. We're doing this instead for n equals start at the end and finish at the beginning of the array. And each time we loop through the array, we're going to change that n value by -1. Now the reason we do this is because we're dynamically removing objects from the array as we're iterating through it. So if let's say we're on bullet number 10, and we remove the 10th index, then our next one that we go to is going to be 9 if we're going backwards like this. And so the whole rest of the array will be unaffected that we're about to iterate through. However, if we were going through like this, starting at 1 and ending at the array size, then if we remove the first index, for example, let's say we remove index 1, then all the remaining values will be shifted over to the left. They'll be decreased. Their index will be decreased by 1. And so in this case, if we removed the first one, and then in the second iteration of this loop, n is equal to 2, well, we just skipped an object. Because that second object is going to get skipped because it got shifted down to the first index when we call table remove. So because of that, if we're dynamically removing elements from that array inside the loop like this, then we want to go through the loop backwards, starting at first with hashtag and then the table variable, which is, this is the size of the table, and then the second value is 1, so that's going to be the last value we evaluate, and then we're going to step through this array by -1 each iteration of the loop. So if you're using an array style table, then you need to step through it backwards if you're dynamically removing elements from that table. You don't have to use an array style table. You could also use the entity universal unique identifier as a key, and then you could use the entity value itself as the value. So the entity class has this get UUID method, and this just returns a string that is a unique identifier for every single entity that ever gets created by every game made with Leadworks ever. So that will always be unique. So you can actually use that, you can safely use that as a key if you want. And then that would allow you to dynamically remove elements from that array a different way. So if we're doing it that way, in this case, we would say we would be doing this with the pairs function. And if you don't remember this function, then I'd suggest you go back and look at the table tutorial in the Lua programming tutorial series. But in this case, we're going to iterate through the pairs, and we're going to use these two variables ID and entity for the key and the value. And then we're going to say, well, if the entity health is less than or equal to 0 in this case, then we can remove that key pair by saying enemy's ID, which is the key, equals nil. When we set it to nil, what that does is it removes that key pair from the table entirely. So 2 different ways of handling things. It's up to you which you think is easier. I usually use the array style tables unless there's a good reason not to. Now another example of entity spawning and management is if you have enemy hordes, especially if you have a game that's like a zombie game. And in this example, we have a horde manager entity, and what it's just going to do is when one zombie dies, it's going to reset that zombie out to a new position as if it's a new zombie. But there's many different ways you can handle this. You could have enemies that come in waves with a certain number of entities with each wave. You could just have enemies constantly spawning, in which case you could like fill up the game with too many enemies potentially, but that might be the gameplay that you want. It's up to you. You could also have waves of enemy attacks that are triggered by an invisible collision object that the player walks into. Like they walk into a certain room and it just sets off, maybe it opens a bunch of doors and a bunch of enemies come running out. It's really up to you. There's a lot of different ways you can handle it, but this is an example that I made, and we'll run it now. So let's just paste that in. And we're going to have a turret that we can control similarly to before. And then we have this horde manager entity, and this is just a pivot. It's not anything that we can see, so it's just kind of this abstract object, but we're going to use it as a container for functions, and it's also going to store all of our enemies, and it's going to handle the updating of them. So let's run the game first and see what it does. Here come the enemies, and I can shoot them. And you can see as when I shoot them, oh, he got me. Okay. When I shoot them, they were respawning out on the periphery of the floor there. So let's take a look at the horde manager entity. Now I've added this spawn enemy function here, and what this does is it creates a new enemy entity with this create cylinder function, and it sets some properties, sets the health to 10, and then it declares a take damage function on the enemy. And then it also declares an update function on the enemy. So this update function will be called each during each call to world update, which is right here. So in the update function, all it does is it smoothly moves towards the turret. So that's very simple. And then I just want to show you one thing that's kind of interesting. Let's take a look at the bullet code, because I've changed this up a little bit. Here it is. Here's our world pick command. So we're picking a path in front of the bullet, and then if there's any picked object, we're going to call add point force. Well, in this case we don't really need it because we don't have a tower of boxes we're shooting down, but it doesn't really hurt anything having it in there. And now this is really key here. We're looking for a function called take damage. So we're saying if is function pick.entity.takeDamage, then we're going to call pick.entity colon take damage 10. This take damage function is, we declared that, didn't we? That's that function. And if we have a different type of object with a different function that's called take damage, that will also get called. So here's our take damage function, and we're passing the amount of damage to it. In this case, when we called it, we passed 10 to it, so it's going to do 10 damage. And we say if self.health is greater than 0, then self.health equals self.health minus damage. So we're subtracting this amount of damage from our own health. Let's go back up there again to where we're actually calling this. You see what I did here? I said if is this thing take damage is a function, then we're going to call it like a function and we're going to pass 10 to it. And the bullet doesn't really know or care what this function does. It just knows that if it does find a function called take damage, it's going to call it and it's going to pass 10, the number 10 to it. So the enemy itself is handling how that damage is distributed, like what effect it actually has. So the first thing we're doing is subtracting that damage from the health. And then if the health is less than or equal to 0, so if health equals 0, well, we're going to play this sound. That's our zombie dying sound. And then we're actually going to reset this object. We're just going to make it as if it's a new zombie. We're going to set the health back to 10. We're actually going to increase the speed of the zombies so they get faster as the game progresses, which makes it a little bit more fun. And then we're just going to randomly position it somewhere out on the periphery again. And then, of course, we're going to increase the turret's score by 1 because he killed the zombie. And we're going to update this text tile that displays the score with the turret's current score. So the key concept here is the turret has this bullets table where all the bullets are stored. So the turret has ownership of the bullets, and the turret basically manages the spawning of the bullets. And in this case, the bullets don't have their own update function. The turret is handling the updating and deletion of all the bullets, right? Because all of this is happening inside the turret update function. Now for the enemies, we have this horde manager pivot that we created, and it's just kind of an abstract object. It's not something we can see. But the horde manager is responsible for all of the enemies. It has this enemies table where they are all stored. If the horde manager, for some reason, disappears, all the enemies are going to disappear too, because the horde manager is what keeps them in memory. It keeps them in scope. So the horde manager has the spawn entity function, And then in this case, we're going to give the enemy its own update function so that it will update independently. And then finally, the enemy has this take damage function that the bullet is going to be looking for. And that's a really important concept. Just this idea of I'm interacting with this other object, and if it has this function, I don't care what it does. There might be several different objects with several different functions that act like this that have the same name, but they're different functions. That's okay. I'm just looking for this function called take damage. And if it's there, if it exists, and if it is a function, I'm going to call it. And I'm going to pass the amount of damage to it that I think it should have. And then at that point, the other object itself becomes responsible for how that damage is applied and what effect it has. So this is how your game code gets compartmentalized. And what's really wonderful about that is you can have several different objects with a take damage function, and they can act in different ways. For example, you could have a crate with a function called take damage, and that function could make the crate break apart. You could do that by hiding the crate model itself and replacing it with a bunch of fragments of a model that you've pre-modeled, and then it'll just make it look like the crate is breaking apart. So this is how you can have different objects that react differently, and you can add new functionality into your game without having to rewrite your entire game.